watching RV's Learning Point and I hope you're all doing well. So let me start my today's concept of chemistry, that is chemical reactions and equations. So for a revision, let me first teach you what is valency. Valency is the number of outermost electrons shared by an atom. Valency is the number of outermost electrons shared by an atom. So what do you understand by the outermost electrons? Just for an example, this is an atom X. So I'll just draw the structure of the atom. X is the nucleus, the structure of the atom. These are the electrons present in this atom X. So now how do you identify the outermost electrons? See, the electrons present in the outermost shell. This is the outermost shell, this one. And these are the outermost electrons. So this is what we call as the valence electron. Valence electron. This is what we call as the valence electron. See, the electrons present in the outermost shell of an atom X. I just represented the atom as X. So these are the outermost electrons. This is what is being shared with other atoms. This is what we call as valency. See, in simple words, valency can also be defined as the combining capacity of an atom. Valency can also be defined as the combining capacity of an atom. So, now look at this example over here. I have carbon. Carbon's valency number is 4 and chlorine. Chlorine's valency number is 1. So, when I combine carbon with 4, its valency number is 4 and chlorine with valency number 1, I get, this is called as the crisscross method and we get CCl4. This is what is the product formed due to the valency property of carbon and chlorine. This is all about valency. For an example, take this. Copper oxide reacts with carbon to form copper and carbon monoxide. Copper oxide reacts. See, here they are explaining you that copper oxide and carbon are reacting with each other to form new products, copper and carbon monoxide. So, each time when two or more reactants combine to form two or more products or just a simple product, that cannot be written again and again like this. So, this is a very difficult task, right? So, this is being compacted and written in the form of chemical equations. So, copper can be written as Cu and oxide can be written as O. So, copper oxide, this is the formula of the compound. As I have already told you, formula of compounds are used and carbon C. Just write what is known to you. Copper oxide CuO and carbon C. It to form copper. To form copper and carbon monoxide. Carbon monoxide. So now observe the other words. Copper oxide reacts with. Now this is a plus sign. Copper oxide reacts with carbon to form copper and is another plus. So copper oxide reacts with carbon to form. To form is this one. Now, this is the same as this and this is the same as that. But look at the way it is got simplified over here, right? This is a very difficult thing. This is a very long, you cannot write every time when two things react with each other. So, formula of compounds and symbols of elements are being used so that copper oxide reacts with carbon to give copper and carbon monoxide. Same thing is getting explained even over here and here, but this is just to simplify the task and this is why we use chemical equations. So my next topic is how to write chemical reactions, that is writing chemical reactions. So reactants will be written in the left hand side and products will be written in the right hand side. The reactant side and the product side are being separated by an arrow mark. Okay. Now if we have more than one reactant in the left hand side and if we have more than one product on the right hand side. So what we do is we separate the two reactants. Now let me take X and Y as the two reactants and they form YX. This is just an example. So I separate the two reactants on the left hand side with a plus sign. Now this is when two reactants form a single product. Now what if a single reactant forms two products? That time X, Y gives me X plus Y. Now here on the reactant side there is only one single compound that is being broken down into simpler things. Now this products, there are two products and that is being separated by a plus sign over here. So this is how we separate the two reactants and the two products, by a plus sign in between them, and mainly the reactant side and the product side are being separated by an arrow mark between them. Okay, now we'll go for an example. As written here, magnesium plus hydrogen sulfate gives me magnesium sulfate plus hydrogen. Now here as you can see there are two reactants as well as two products. The two reactants are being separated by a plus sign between them and the two products are also being separated by a plus sign between them. And mainly the reactant side is written in the left hand side, the product side is the products are in the right hand side, and the reactants and products are being separated by an arrow mark between them. Now I think you've understood where we use all this. Now there is another thing that we use, that is we mention the physical state of the reactants and the products. Now magnesium is a solid, hydrogen sulfate is aqueous, magnesium sulfate is also aqueous, and hydrogen is gas. Now this need not be mentioned every time when you write each and every equation, but when it is asked that write an equation along with the physical states of the reactants and the products, then this must be mentioned. So magnesium is in solid state, hydrogen sulfate is in aqueous state. Now what do you mean by aqueous state? When a solid is immersed in liquid state. When a solid is in liquid state, then that state is called as the aqueous state. Now I think you've understood what is aqueous state. Now magnesium is in solid state, hydrogen sulfate is in aqueous state, magnesium sulfate is in aqueous state, and hydrogen is in the gaseous state. Now hydrogen can also, this gas symbol can also be told, can also be written like this. The arrow facing upward also it symbolizes the gaseous state. Now besides the solid, liquid, gaseous, and we also have this, the arrow mark facing downward. Now this represents the precipitate state. Now what do you mean by a precipitate state? See, when a reaction takes place and solids like magnesium over here or anything, just for an example, the two reactants, they get reacted to form a product, but after the products form also an insoluble particle remains, and that insoluble particle generally it settles down. Now that is what we call as precipitate. Now for an example, now let me just give you one example of precipitate reaction. That is, I have sodium chloride plus silver nitrate, that gives me silver chloride and sodium nitrate. Now sodium chloride is in the aqueous state. Sodium chloride, this is the common salt that we use in our daily life. So that is represented as NaCl, that is sodium chloride. And then we have silver silver nitrate. Silver nitrate is also in the aqueous state, but you have AgCl, that is silver chloride. Silver chloride is in the precipitate state. This is in the precipitate state. This precipitate state is something that is insoluble in water, that is water insoluble. This generally settles down after the reaction. So this is in the precipitate state. And sodium nitrate. Sodium nitrate is also in the aqueous state. Now, after this sodium chloride reacts with silver nitrate, it forms sodium nitrate and silver chloride. Silver chloride remains in the beaker like so. Just in some corner of the beaker, it just settles down. Even if you have this, just settles down, and this is what we call as the precipitate. This is the precipitate state. Next, I think you understood how to write chemical equations, but there are two types of chemical equations. That is, CE represents chemical equations, that is balanced chemical equation and unbalanced chemical equation. See, now balanced and unbalanced. Unbalanced chemical equation is also called as the skeletal chemical equation. It is called as the skeletal chemical equation. Now, balanced and unbalanced. Now, we are going to learn how to change the skeletal chemical equation into balanced chemical equation. First, let me give you examples of balanced and unbalanced. See, for balanced chemical equation, you have Mg plus O2 gives you 2MgO, where you add a 2. This 2Mg plus oxygen gives you 2 magnesium oxide, that is magnesium oxide. Whereas in an unbalanced chemical equation with the same examples, you have Mg plus O2, that gives you 2MgO. Now if you notice, see, here you have magnesium. On the reactant side you have magnesium. Magnesium over here. First write down the reactants and products on both sides. Now see, here you have magnesium. How many magnesium do you have? 2. So just write down 2. Oxygen 2. Now magnesium on the product side is 2 and oxygen on the product side is also 2. Now you can observe, see, 2, 2. It is same. So this is a balanced chemical equation. Whereas here, if you observe, Mg you have only 1, whereas oxygen 2. Here on the product side you have 2 Mg and you have 2 oxygen. Now here you can easily say that there is a difference. See, on the reactant side you have only 1 Mg, that is 1 magnesium, but on the product side you have 2. Now this is an unbalanced chemical equation or a skeletal chemical equation, and this can be changed by just adding a 2. Now this is how you balance chemical equations. So the general definition of the balanced chemical equation is atoms of elements on the reactant side and the product side are equal. See, if the atoms of elements on the reactant side and the product side are equal, then it is said as the balanced chemical equation. Whereas if the atoms of elements on the reactant side and the product side are not equal, if they are not equal, then that is called as the skeletal chemical equation. I think you all understood this. See, I have told you what are balanced chemical equations, what are unbalanced chemical equations. See, didn't you get the doubt that why should we follow? Why should we balance chemical equations? Right? See, there is a reason for everything, and the reason why we balance chemical equations is we follow a law. This law You are already familiar with this law. You've learned this in your 9th standard. That is the law of conservation of mass. Yes, this is the law of conservation of mass. So, see, the law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Mass can neither be created nor be destroyed in a chemical reaction. See, this is what you are familiar with, but this can also be told in simpler words. That is, see the mass of an element. See the mass of an element at the beginning. The mass of an element at the beginning of the reaction. For example, if this is x at the beginning, x plus y gives me xy. So this is just an example. See the mass of an element at the beginning. The mass of x. Let me take the element x. The mass of element x at the beginning. See, this is the beginning of the reaction, and at the beginning of the reaction, if for suppose this is x dash, the mass is x dash, and at the end of the equation also the mass of x must be x dash. That is, mass of the element, any element, mass of any element at the beginning of the reaction should and will be equal to the mass of that element at the end of the reaction. This is the law of conservation of mass, and that is why we follow this to make the reactions balanced. That is why we balance chemical equations. See, now let me explain you the types of chemical equations. Mainly there are 4 types of chemical equations. Let us go one by one. So the first type of chemical equation is the combination reaction. So as the name suggests, combination. Combination when 2 things or 2 or more things combine. See, generally also 2 or more things combine, we will just say combination. In the same way in chemistry, combination reaction means when 2 or more reactants, when 2 or more reactants combine, when 2 or more reactants combine to form, generally form a single product. Okay, so this is the definition of combination reaction. See, it is very simple. When 2 or more reactants combine to form, that is 2 or more simple reactants combine to form a single product or a single compound. This is what we call a combination reaction. For example, carbon plus oxygen gives carbon dioxide. Now, carbon plus oxygen gives carbon dioxide. See, there is 2, more than 1, right? 2 or more. So, 2 reactants combine to form a single product. This is called as a combination reaction. This is a very simple combination reaction. So, carbon plus oxygen are the 2 reactants that combine with each other to form a single compound or a single product, carbon dioxide. Now, let's go to the second type of chemical reaction, that is the opposite of combination reaction, that is the decomposition reaction. The decomposition reaction. Now, as the name suggests, decomposition. Decomposition. When we say decomposition, when like a single thing divides, it divides, right? So decomposition, when it breaks down. So when a single compound breaks down, when a single compound breaks down into simpler products, this reaction is what we call as the decomposition reaction. Now, a single compound breaks down to form simpler products. It can be like 2 or more simpler compounds, and this is what we call as the decomposition reaction. Now, one very simple example of the decomposition reaction is calcium carbonate. Calcium carbonate, this is a single compound that is breaking down into calcium oxide and carbon dioxide. Now see here, a single compound, see, a single compound breaks down into simpler products, two or more simpler products. See, two simpler products. See, this one thing got broken down into two. This is a decomposition reaction, and it is a very basic decomposition reaction. Also, there are three subtypes of decomposition reaction. Now, let's speak about the three subtypes of decomposition reaction. First one being the thermal decomposition reaction. Now, the first one is the thermal decomposition reaction. Now, what do you mean by thermal? You also have thermal electricity. Remember, thermal means heat. As you all know, thermal means heat. Now, thermal decomposition reaction is a reaction where a single compound breaks down into two or more simpler products when heat is involved. With the use of heat, a single compound is getting broken down. Now, for an example, let me take CaCO3, as told before, that is calcium carbonate. Calcium carbonate, in presence of heat, breaks down into calcium oxide and carbon dioxide. Now, calcium carbonate in presence of heat breaks down into calcium oxide and carbon dioxide. Now, this is an example of thermal decomposition reaction. Now, the second subtype of decomposition reaction is the electrolysis. Now, electrolysis. What does electrolysis mean? See, that gives you something about electricity, and lysis refers to break down. Now, when you combine that electricity and breakdown, what do you get? Now an example for electrolytic decomposition reaction or electrolysis is water molecule in presence of electricity. Water molecule in presence of electricity breaks down into two simpler byproducts, that is 2H2 plus O2. Now, a single compound breaks down into two simpler products in presence of electricity, and this is what we call as electrolysis or electrolytic decomposition reaction. Now, the third type of decomposition reaction is the photochemical decomposition reaction. The photochemical decomposition reaction. Now, remember photosynthesis. What is photosynthesis? See, the process in which, with the presence of sunlight, the plants prepare their own food is called as photosynthesis. See, this looks similar to that, right? Photochemical. Now, photochemical. In presence of light, in presence of sunlight or light, in presence of sunlight or in the presence of light, when a single product breaks down into simpler ones, into simpler byproducts, that is called as photochemical decomposition reaction. Now, that can also be done as an activity, but for now, just see this example. AgCl. What is AgCl? Silver chloride. Now, silver chloride breaks down in presence of sunlight. In presence of sunlight, silver chloride breaks down into silver plus chlorine. Now, in presence of sunlight, a single compound breaks down into simpler byproducts, that is silver and chlorine. Silver chloride breaking down into silver and chlorine. Now, this is a photochemical decomposition reaction, and these are the three subtypes of decomposition reaction. Thermal decomposition, that is when we use heat to break down a single compound into two or more simpler ones, and electrolysis or electrolytic decomposition reaction when we use electricity to break down a single compound into simpler byproducts. And the third one, the photochemical decomposition reaction where we use sunlight or light to break down a single compound into two or more simple byproducts. This is the decomposition reaction. Now, the third type of chemical equations is third type of chemical reaction, the displacement reaction. Now, displacement reaction. Now, displacement. So, what do you understand by displacement? See, when a more reactive element displaces or occupies the space of a less reactive element, this is what we call as the displacement reaction, where a more reactive element on the reactant side, mainly remember on the reactant side, a more reactive element displaces the lesser reactive element. For example, I take zinc, as I've already told, zinc plus hydrogen sulfate gives me zinc sulfate plus hydrogen. Now, how do you understand? See, zinc, hydrogen, whereas over here it is changed. Zinc has occupied the place of hydrogen. Zinc is a more reactive element. Zinc is more reactive than hydrogen. That is why zinc displaces hydrogen. Zinc occupies the space of hydrogen in the compound hydrogen sulfate and thus forming zinc sulfate in the product side along with hydrogen that is left. Okay, so zinc occupies the space, or much like zinc displaces hydrogen in hydrogen sulfate to form zinc sulfate plus hydrogen. Now, this is the displacement reaction. Now, displacement reaction, a more reactive element displaces a lesser reactive element, especially only on the reactant side, not on the product side. Now, the fourth type of chemical reaction is the double displacement reaction. Double displacement reaction. See, as the term suggests, double displacement. See, you already know what is displacement reaction. The more reactive element displaces the lesser reactive element, whereas double displacement reaction here, exchange of elements take place. Here exchange, there the more reactive element displaces the lesser one, but here exchange takes place. For example, AgCl, that is silver chloride plus sodium nitrate gives me sodium chloride plus silver nitrate. Okay, this one is not that. So, silver chloride plus sodium nitrate gives me sodium chloride. Now, can you observe AgNa, that is silver, Ag, that is argentum, that was its Latin name, but now it's been changed to silver. Now, Ag and sodium, they exchange here. AgCl, that is silver chloride, becomes sodium chloride, and sodium nitride becomes silver nitride. Now this is what we call as the exchange of ions, and this is called as the double displacement reaction. Simple double displacement reaction, exchange of elements take place. Now the fifth type of reaction is the oxidation reaction. Oxidation reaction, as the name suggests, oxygen or an electronegative ion gets added. See, oxidation reaction is where oxygen or electronegative ion gets added. The first thing, and it can also be told as a reaction in which hydrogen or electropositive ion gets removed, or in electronic concept it can be told that oxidation is a process where loss of electrons takes place. Loss of electrons. So, loss of electrons. Now, simple example is carbon plus oxygen gives me carbon dioxide. In this example, carbon is single. When we add oxygen to it, this reaction is what we call as the oxidation reaction. As you can see, there is the addition of oxygen. Now this is what we call as the oxidation reaction. Now the next reaction is quite opposite to the oxidation reaction, and that is called as the reduction reaction. Now, the only change between the oxidation reaction and the reduction reaction is oxygen or electronegative ion gets removed in the reduction. It gets removed, and hydrogen or electropositive ion gets added. Hydrogen or electropositive ion gets added in the reduction process, and according to electronic concept, reduction reaction is a process in which gain of electrons occurs. Now, simple example of how we can explain the reduction reaction is, now here you can observe sodium plus hydrogen. Now this is a reduction reaction. Why? Because hydrogen is added. Addition of hydrogen is occurring. That is why this is a reduction reaction. Now redox reaction is the one where both oxidation and reduction process occurs. Now let me explain you redox reaction. Redox. See, as you can observe, red, it is reduction, and of oxidation. Now see, a reaction in which both reduction and oxidation occurs. This reaction is called as the redox reaction. For an example of redox reaction, manganese oxide plus hydrochloric acid gives manganese chloride plus chlorine plus hydrogen. Now just observe, this is an example of redox reaction. Now how do you identify this as a redox reaction? Just observe, You have manganese with oxygen, and you have manganese with chlorine. Now, oxygen is an electronegative element, an electronegative ion, and this is an electropositive ion. Now, oxygen is getting reduced, oxygen is getting removed from manganese, and that is why when oxygen is getting removed, what is the reaction called? Yes, it is called as reduction. A reduction is occurring between manganese and, observe, hydrogen. Here hydrogen had electropositive ion, whereas on the product side it has oxygen, that is an electronegative ion. So here hydrogen is getting oxidized, that is oxidation is occurring. Manganese, in the same reaction, in the single reaction itself, one element or one reactant is getting reduced, whereas the other one is getting oxidized, and this is what we call as the redox reaction. Redox reaction defines, see, a reaction in which reduction as well as oxidation occurs in a single one. In a single reaction, if reduction and oxidation is occurring, then that is known as the redox reaction. Okay. Now, see, oxidation is the main reason of the occurrence of corrosion or corroding of the material. See, this occurs when materials get oxidized. Materials oxidizes with, firstly, air molecules in the presence of water. Now, corrosion occurs when the materials or the particles gets oxidizes with the air molecules in the presence of water. Now, especially iron. Example, iron. Symbol Fe-ferrum. Okay. Iron gets corroded the most, and every year a lot of money is spent. Why? To repair or to replace rusted or corroded ones. So every year a lot of money is being used to repair or replace the corroded iron. So this corrosion is when the materials or the particles oxidizes with air molecules in the presence of water. This is called as corrosion, or in simple words, rusting. And iron is the material which gets most rusted or most corroded when it comes in contact with air and with water. So generally there are many methods which we use to prevent corrosion or rusting. So that I will be telling you in your third chapter, metals and non-metals. But for now, this is enough. Now the next one is rancidity. Rancidity. Okay. So, what is rancidity? The process by which the taste and smell of food particles change. See, the process by which the taste and smell of food particles change. It gives out a bad odor, it gives out a different and a very bad taste, and we feel like it is okay, it has got rotten, and that is when we call rancid. It has got rancid. So that's it for today. I'll be back with another session. Until that, take care. Please do like, share, comment and subscribe to my channel, RV's Learning Point.